Question 24. A big wheel is modelled as a circle with centre O and radius 15 meters. The wheel turns in an anti-clockwise direction. The lowest point on the wheel is always 2 meters above horizontal ground. C is a point on the wheel h meters above horizontal ground. The angle COB x degrees, and we need to show that h equals 17 minus 15 cos x. So we're looking for this length. So in order to calculate that, we'll first need to know this length here and the total length. The total length is quite straightforward. We know the radius is 15, so the distance from O to the edge of the circle is also 15. We just need to add on that 2. That means the distance from O to B is 17. If we want to calculate this length here, we're going to have to use trigonometry. We want this length, and we have this length here, that's the hypotenuse, and this related to x is the adjacent. So we need to think of which trig ratio includes that, and that's cosine. So we can write cos x equals adjacent over hypotenuse. In this case, we can call adjacent simply a, and the hypotenuse is 15. So the adjacent side is simply 15 cos x. Next, we need to figure out what h is. If we know that 17 is the full length and this side is 15 cos x, we can take h, 17, take away the smaller length here, 15 cos x. That's our 2 marks. Question 24b. D is a point on the wheel and the angle DOB is 120 degrees. Work out the height of D above horizontal ground. In the first part of the question, we said that this height was h, which we figured out an expression for, which is 17 minus 15 cos x. To find out the height of h, we need to substitute x, the angle, 120 degrees. So we'll say h is 17 minus 15 cos of 120. Is 17 minus 15 minus a half, which equals 24.5 meters. Question 24c. Here is a sketch of the graph h equals 17 minus 15 cos x for one complete turn of the wheel. P is the highest point on the graph. Work out the coordinates of P. So the wheel starts turning here from the bottom, and it turns anti-clockwise all around the circle until it returns to 2. And we can see that from the graph. It starts at 2, and it goes up to the highest point, and then returns to 2. We know the highest point is up here, which if we're thinking in terms of our angle x, x has to equal 180 degrees at the highest point of the circle. So all we need to do is substitute this into our equation for h to work out the coordinates. We know that x is 180, we can put that in immediately. And we have h equals 17 minus 15 cos 180. Cos of 180 is minus 1, so we can write h equals 17 minus 15 times minus 1, which is 17. Take away negative 15, which would be plus 15, so h is 32.